electrical energy can be converted to heat energy. This is called Joule effect. In 1821, a German scientist Seebeck discovered that heat energy can be converted to electrical energy. The Seebeck effect. If two appropriate dissimilar metals are joined at both their ends to form a circuit loop, and the two junctions are kept at different temperatures, then EMF is developed in the loop. This effect is called the Seebeck effect. The circuit formed by a pair of such junctions is called a thermocouple, and the metals forming the thermocouple are called the thermoelements. Of the two junctions kept at different temperatures, the one kept at a higher temperature is usually called the test junction, and the one kept at a fixed lower temperature is called the reference junction. The EMF produced, called the thermo EMF, is of the order of few microvolts per degree Celsius. Direction of the EMF depends upon the nature of metals and the temperatures of the junctions. For example, in the case of antimony-bismuth thermocouple, normally the direction of EMF is from antimony to bismuth for the junction at the lower temperature. Different metals have different values for the number density of free electrons. Further, this number density also depends upon the temperature of the metals. Under these circumstances, the diffusion of electrons across the cold junction and hot junction of dissimilar metals does not occur at the same rate, resulting in some net current of electrons. This causes the thermo EMF. This type of thermo EMF is called the Seebeck EMF. When the temperature of the test junction is varied, keeping the reference junction temperature fixed at 0 degrees Celsius, different values of thermo EMF are obtained. When these values are plotted against the test junction temperatures, a parabolic graph is obtained. Depending upon the metals used for forming the thermocouples, the parabolic graph can also appear inverted. Temperature at which thermo EMF is maximum is called the neutral temperature, and that at which the thermo EMF is 0 is called the inversion temperature. The relation between the thermo EMF and the temperature can be expressed empirically through an equation. Thermo EMF E is equal to alpha T plus half beta T square. The constants alpha and beta depend upon the type of metals forming the thermocouple. The quantity dE upon dt is called the thermoelectric power. The value of dE upon dt at a given temperature depends only on the type of metals forming the thermocouple. when electric current is passed through a junction of two dissimilar metals, there is an exchange of heat between the junction and the environment. This effect is known as the Peltier effect. A scientist named Peltier discovered in 1834. It has been established experimentally that the quantity of heat exchanged near the junction is proportional to the amount of electric charge crossing the junction. On reversing the direction of the current, the sign of the heat exchange reverses. That is, if the junction were releasing heat, it would start absorbing heat from the environment. If heat is absorbed at the junction, it means that the heat energy is being converted to electrical energy. The heat is released, it means that the electrical energy is being converted to heat energy. The amount of heat released or absorbed at the junction per unit electric charge crossing the junction is called the Peltier coefficient or the Peltier EMF pi AB. The value of pi AB depends on the type of metals and the temperature of the junction. When an electric current is passed through a conducting wire, by keeping its different points at different temperatures, then, as a result of unequal temperatures on the wire, either heat is absorbed or heat emitted at each point. Heat produced or heat absorbed is known as Thomson heat. This phenomenon is known as the Thomson effect. The EMF generated due to the temperature difference between different points of the conductor is known as Thomson EMF. If the temperature difference between 2 points is 1 degree centigrade, then the Thomson EMF between these points is known as Thomson coefficient sigma. Coefficient sigma.